Good afternoon. On today's Angry Bulletin, scientists have discovered even more compelling evidence for life on the red planet. We need to find out for certain, and yet NASA seems hesitant to spend the necessary money to bring the samples back that could prove once and for all whether there's life elsewhere in the solar system besides on our own planet. But it appears that the Boeing Corporation, of all people, has a very straightforward plan to find out once and for all. But can Boeing do anything right anymore? All of this and more coming at you on the Angry Astronaut right now. Good afternoon, and once again, welcome to another Angry Bulletin. Not calling this one an Angry Alien Bulletin, although technically I'm talking about alien life on another planet, but not necessarily complex life. Nothing any more complicated than bacterial life, although honestly, we can't say for certain when it comes to Mars, because for the most part, we have done little to nothing, actually, to search for life on Mars. It may be difficult to believe, but the only life detection experiment that was ever sent to Mars was sent way back in 1977. The only experiment designed to detect the presence of active life was on Viking 1 and Viking 2. And since then, we have sent nothing else that was specifically designed to look for life. And, interestingly enough, the only experiment that we ever sent to Mars to look for life had a positive result. It detected life. Again, according to the scientist who headed up that particular experiment, the two scientists responsible for it, Dr. Gilbert Levin, Dr. Patricia Strott, who are both sadly no longer with us, well, according to them, they found life way back in the 1970s. All of that having been said, though, the rest of the scientific community, predictably, is not as convinced. Many of them think that there's no evidence for life on Mars at all, which I think is a ridiculous conclusion given the fact that an experiment was carried out that actually did show that life was present. I mean, a great deal of effort has been made over the last half century to try to create conditions where an abiotic situation, a non-living cause, could have brought about the results of the experiment that took place, and nothing has ever worked. Up to this point, the only thing that has made the life detection equipment, otherwise known as the label release experiment on the Viking landers, produce the results that they did have been bacterial life. So kind of weird to say that there's no evidence at all. But in some ways, I'm starting to think that there's a pattern here. There's a reason for this dominant paradigm amongst the scientific community that Earth is the only planet with life, that there's no evidence of any life, any civilizations existing anyplace else. It kind of runs hand in hand, and yeah, this is going to sound a bit like a conspiracy here. I don't think it actually is. It is rather just sort of what people would like to believe right now. It runs hand in hand with the whole global warming thing. The idea that if we don't do something significant about the crisis currently facing human civilization, the fact that our pollution may render this planet either uninhabitable or at least very difficult for humans to survive on, well, the tragedy of that is going to be universe shattering because there's no evidence for life anywhere else. Life may not exist at all anywhere else, which means we better do something about this. This is the only planet we have, and we may be the only intelligent species in the galaxy, in the universe, in fact, and so we have a huge obligation to protect all of that. Now, I don't see why the human species, human civilization, and the life that exists on Earth would be any less precious or any less significant if there were life on every other planet in the universe, because The life on this planet still should be pretty damn unique, but in any event, just seems to me that it does go kind of hand in hand with the we must preserve the Earth school of thought. Now, do I think this is some sort of conspiracy to continue the hoax of global warming and all that? Well, no, I don't. I actually believe that there's a very strong possibility that human civilization is contributing quite a bit to the carbon dioxide that's in our atmosphere. And the more carbon dioxide that's in our atmosphere, the worse the temperature gets. We have a very good example of what happens when you put too much carbon in the atmosphere here in our own solar system, and that is, of course, Venus, a planet of ungodly temperatures, horrible pressures, and all caused by too much CO2. No, I don't think that. I just think it kind of goes hand in hand with their whole world view, and therefore we have this dominant paradigm that life exists only here. There's no evidence for life anywhere else, and so that's why we have to work extra hard to preserve the life that exists on this planet. But regardless of what the reasons might be, the reality is there is more and more evidence all the time piling up that Mars does indeed have life, and that Mars is actually still an environment conducive to the existence of certain kinds of life. That all of the samples that the Perseverance rover has taken up to this point, the evidence that it's gathered up is probably sitting right there in all of those test tubes that it's deposited on the Martian surface. And we need to go get them. And unfortunately, the sample release mission that was supposed to go get them has fallen into some significant trouble because, one, it's too complicated, and two, it's too expensive. Well, regardless of the expense, it is vital that we learn whether or not there is life on the Martian surface and what form that life happens to be taking. Unfortunately, there is a very simple solution that may not be ridiculously cheap, may still be a pretty pricey solution, but there is a very simple solution to bring these samples back. And so we're going to find out why I think that there is almost certainly life on Mars, existing life, not just life in Mars' ancient past, but life that still exists today, and what we can do to go get it.
First of all, Viking is a fantastic venture. I mean that literally. It's probably the most sophisticated spacecraft ever designed for any purpose. It's going to Mars, it's going to land on Mars, and it's going to orbit around Mars at the same time.
I think Viking is one of the most ambitious projects ever conceived by the mind of man. I mean, it is incredibly complicated and audacious in its design.
Okay, so admittedly, I was wrong about the date of the Viking missions in my introduction. Allergies are taking a terrible toll on my ability to function right now. Sorry about that. It was 1976 when Viking 1 and Viking 2 set down on the surface of the red planet, and the number of discoveries that these spacecraft made were pretty mind-boggling, really. We got some of the first detailed images of the Martian surface, for example, including the legendary face on Mars and that whole Cydonia region that continues to stir up controversy to this day. But the most important experiment that were on the Viking missions, in my opinion, were the label release experiment. And the idea behind this experiment was to release nutrients into the Martian regolith, nutrients that bore a great deal of similarity rarity to the types of nutrients that would have existed in primordial Earth, something very fundamental that basic bacteria would probably want to devour, and then treat them with radioactive compounds so that if they were consumed by bacteria, it would give off these radioactive emissions. It was a modified version of a test that's used to determine whether or not there's bacteria present in drinking water. And it turned out that this experiment yielded some amazing results over and over again, both with Viking 1 and Viking 2. By the way, the label release experiment never produced a false positive here on Earth, has yet to produce a false positive under any circumstances, as they've tried to, as I said before, find some sort of abiotic method that the experiment could have produced the results that it did. And in addition to that, the Viking lander treated the samples with a significant amount of heat to determine if the same things would happen after you had cooked the samples. Well, it didn't, as expected. If you blasted the samples with heat, it should have killed all of the remaining bacteria, and the test should then give a negative result, which it did. Then NASA decided to blast another sample with a lesser amount of heat, an amount of heat that would have killed some but not all of the bacteria, to see what that would do. And sure enough, the label release experiment did indeed produce some emissions, but 60% less than before the samples had been cooked with this amount of heat. Again, as expected, if there would be something alive in the samples. And to make it even more complicated, NASA decided that perhaps the soil, after being subjected to cosmic rays and solar radiation, might have changed its chemical composition in such a way to modify the results, to skew the results. So the Viking lander turned over a rock on the surface of Mars that should have shielded any regolith underneath it from radiation, and then sampled the regolith underneath the rock, and sure enough, the results came out positive. Very compelling evidence, but the problem is Viking detected no evidence of organic molecules during its tests as well. Although the instruments it was using to detect organic molecules at the time were not very sensitive, but nevertheless, NASA decided, at the time anyway, that the evidence was inconclusive and left it at that, although Dr. Gilbert Levin and Patricia Strott insisted to their dying day that they had found life on the surface of Mars. And ever since then, the evidence has continued to mount. The Curiosity rover detected, for example, enormous amounts of methane present in the atmosphere, still trace amounts of course, but very sharp spikes of methane being present, and only at certain times of the year, only during summer months. This also corresponds to what we would expect if there were life still existing on the Martian surface, with methane being more prevalent during the warmer summer months when bacterial life might flourish. Of course, the Martian Trace Gas Orbiter detected no methane whatsoever, which was very strange indeed, indicating that perhaps the methane was only in the particular crater where the Curiosity rover was doing its research. Why that would be remains a mystery, but there is one compelling theory. The idea is the methane is trapped beneath the Martian surface, much in the same way that methane is trapped beneath the tundra in Siberia on our own planet. And when the Curiosity rolls over a pocket of methane and cracks the surface of the regolith, especially salty, brittle regolith, which exists in some of the regions where the Curiosity has been active, well, when that surface gets cracked, methane is released, sometimes in larger quantities depending on the size of the deposit, and that's why the Curiosity can detect these sudden emissions of methane, but there isn't enough of it to make a big difference in the Martian atmosphere to where the Trace Gas Orbiter could pick it up. Now, of course, the scientists who came up with this theory also said that this was an indication that the methane is abiotic, that it was being brought about by some sort of geological means. But if that's the case, then why does it happen seasonally? Why would Curiosity be rolling over pockets of methane only during the summer months and at no other time? It makes no sense whatsoever. It seems far more likely to me that that methane is being created by subsurface bacteria, and Curiosity is running over some larger colonies of this bacteria during the summer months while these colonies are flourishing. Now, in addition to that, the Curiosity has also detected molecular oxygen in the atmosphere in rather large quantities. Again, life being one of the more obvious explanations for this, but still not conclusive. But the evidence continues to pile up, especially recently. For example, the Curiosity rover has also detected a significant amount of manganese being present along what appears to be an ancient Martian shoreline. Now, this much manganese, at least on Earth, is created only by biological processes. But predictably, the scientific community is refusing to connect this discovery with the possible existence of Martian life. Quote, "It is difficult for manganese oxide to form on the surface of Mars, so we didn't expect to find it in such high concentrations in a shoreline deposit," said Patrick Gazda of Los Alamos National Laboratory Space Science and Applications Group and lead author on the study. On Earth, these types of deposits happen all the time because of the high oxygen in our atmosphere produced by photosynthetic life and from microbes that help catalyze those manganese oxidation reactions. On Mars, we don't have evidence for life. Let me say that again. On Mars, we don't have evidence for life. Of course, we've only tested for life once, or twice if you include the Viking 2, and both of those experiments showed a positive result, but no, we don't have evidence for life. Well, let's go on. And the mechanism to produce oxygen in the Mars' ancient atmosphere is unclear, so how the manganese oxide was formed and concentrated here is really puzzling. Yeah, really puzzling if you have a razor-brained approach to science. Fortunately, there's a team of scientists at the University of Minnesota who aren't quite so razor-brained. Instead, what they've done is research what are called perchlorate brines to determine whether or not life might flourish in this type of environment. Why are they doing this? Well, because we've determined in the last couple of decades that the Martian regolith is loaded with salty perchlorates. Now, perchlorates are ordinarily quite poisonous and not very well suited to even bacterial life. However, what they wanted to do is determine whether or not two different types of ribonucleic acids and protein enzymes from Earth could actually function in these salty perchlorate brines. So combining perchlorates with water and salt to see whether or not certain types of life might flourish. The research produced some amazing results. All of the RNAs work surprisingly well in perchlorate brines. Protein enzymes did not function as effectively as RNAs. Only proteins evolved in Earth's extreme environments, such as those living at high temperatures or in high salt, could function. In perchlorate brines, RNA enzymes performed unique actions, like generating new molecules that incorporate chlorine atoms, a reaction previously unobserved by scientists. Quote, "Taken together, these results show that RNA is uniquely well suited to the very salty environments found on Mars and could be found on other bodies in space." By the way, this is Dr. Engelhardt, the head of this particular team at the University of Minnesota. She goes on to say, quote, "This extreme salt tolerance could influence how life may have formed on Mars in the past or how it is forming in the conditions on Mars today." And last last October, a team of researchers from Northwestern University made another amazing discovery. They found out that ancient bacteria could survive close to the surface on Mars much longer than previously assumed. And when the bacteria are buried and thus shielded from galactic cosmic radiation and solar protons, they can survive much longer. These findings strengthen the possibility that if life ever evolved on Mars, its biological remains might be revealed in future missions. And because the scientists proved that certain strains of bacteria can survive despite Mars' harsh environment, future astronauts and space tourists could inadvertently contaminate Mars with their own hitchhiking bacteria. Quote, "Our model organisms serve as proxies for both forward contamination of Mars as well as backward contamination of Earth, both of which should be avoided," said Michael Daly, a professor of pathology at Uniformed Services University of the Health Sciences and member of National Academy's Committee on Planetary Protection, who led the study. Importantly, these findings have biodefense implications too, because the threat of biological agents such as anthrax remain a concern for military and homeland defense. We concluded that terrestrial contamination of Mars would essentially be permanent over time frames of thousands of years. This could complicate scientific efforts to look for Martian life. Likewise, if microbes evolved on Mars, they could be capable of surviving until the present day. That means returning Mars samples could contaminate Earth. So let's add all of this up. The presence of methane in unusual quantities, the presence of oxygen in unusual quantities, the presence of manganese in unusual quantities, the results of the label release experiment, and then finally, numerous tests proving that various types of bacteria could not only survive on Mars, but flourish even just a few centimeters beneath the surface. So that being the case, it is very likely that the sample containers that the Perseverance rover has gathered over the last several years, now waiting for us on the surface of Mars, contain flourishing life, or at least the evidence of life, just waiting for us to go and pick it up. So what's the problem? Well, as many of you have probably heard, it's been determined that the sample return mission, at least as originally conceived, is both too expensive and too complicated to move forward with. It involves not only sending a whole new lander to the surface of Mars, a lander that would have a rover capable of retrieving these samples, or perhaps making use of helicopters similar to the ones we've been experimenting with up to this point on Mars to retrieve the samples one way or another, gathering them back to this lander, and then the lander launching a rocket loaded with these samples into Martian orbit. From there, a European orbiter rendezvous with the rocket and picks up the samples, and that orbiter returns to Earth. There are so many things that can go wrong with this process. It's also ruinously expensive, and it is anticipated that it's going to be the 2040s before it's even ready to go. That is absolutely unacceptable. But amazingly, Boeing has come up with a solution. Let me tell you, I'm not saying that they've got the answer, but they do have an important component of the answer. It's not cheap, but it's simple, and I think it will work. Step 1, use an SLS to transport a much bigger, much more resilient lander to the Martian surface. Why would you want to do that? Well, because the bigger the lander, the bigger the onboard rocket and the more fuel that rocket can carry. The objective is to launch a rocket that's big enough and has enough fuel to escape Mars gravity, completely eliminating the need for that orbital rendezvous and also returning the sample to Earth much more quickly and much more expeditiously. So it's as simple as that. And the reason you need an SLS is because this is going to be a big, heavy lander. You're probably talking anywhere between 10 and 20 tons, and only the SLS is capable of doing that in a single launch. In theory, Starship could do it too, but only after lots of refueling. SLS can get the job done in one shot. I'm not saying Boeing should design the lander or anything else in this mission. Just get the mission to Mars and have somebody else build the lander. Perhaps the Europeans even. That would be a way to keep the cost down. Or perhaps ESA could design the onboard rocket and re-entry craft. And by the way, I think that it's probably a better idea to not have a re-entry craft at all, but as some of these scientists are suggesting, avoid the possibility of contamination and have it rendezvous with the lunar gateway instead, and have it experimented on by the scientists on the gateway before we risk taking foreign bacteria back to our own planet. Just a thought, but that's one of the most important functions of the gateway, is to serve as a quarantine lab. I think this is a good plan, in spite of the fact that we're using SLS, and yeah, it's going to cost a couple $2 billion to do it, but really the cost of the rocket is not what's going to be the most expensive thing about this mission anyway. And if you can get it done quickly and get it done simply with the maximum chance of success, well, I think that that's a very good solution indeed. I would like to thank the following awesome new Patreon members: Starchface and Kite, and also Keith Mabe, I think, or Mabe, and then Larry Walker, Sebastian, and Adam Eidinger. And in addition to that, some folks increased their membership as well. Roger Slightum, thank you so much, and also Alita Conquering Angel. Because of your support, we're getting ever closer to that 1% threshold, and also to our next milestone where I'll be releasing another Patreon exclusive video to accompany the two I've already released this month. So thank you very much for watching, everybody. Please like, please subscribe, and as always, stay angry about space.